G'day everyone. I'm Brian Young, so I'm a regional sales agronomist for PGW Seeds based down in Gore, which is down in Southland. Today I've got Colin Fergusson from AgResearch. So welcome, Colin.
Thank you, Brian.
Yep, I'll just let you introduce yourself, Colin, and what you do and where you're based.
Okay, well, I'm based at Invermay Agricultural Research Centre, work for AgResearch. Entomologist is a technical term for what I do, but really I think of it more in terms of pasture pest management particularly. So it's trying to research and put into practice some technologies that we can use to mitigate the impact of pests on farm.
Yeah, absolutely, and some of these pests are quite devastating in what they can actually do. So I guess we'll go through some of them. Some of the obvious ones like grass grub, it's sort of affects the whole of the country, doesn't it? So
yes, it does. Apart from the very top of the North Island, it's our most significant pest. It's certainly the one that has the most economic impact to us, and it's not going anywhere in a hurry. It's something we're going to have to deal with for a long time to come yet.
Yeah, that's right. I guess within grass grub, there's actually different species as well, isn't there, which can be a bit confusing.
Yes.
Yeah.
Yes, we tend to talk about one species in particular, and that's the common grass grub, and that's the most prevalent. That's the shiny brown beetle that we see, and it's the fairly sort of large white grub that we find in our pastures with a solidly coloured tan head. But we do have other species as well, as you say. We have several species of Odontria which are spread around the country, or chafer beetles they're often called, larger than grass grub. Tend to be more devastating when we get them, but they're not nearly as common. And the other one we have, which is quite similar, is manuka beetle, and there's several species of those as well. Okay. And they're smaller than grass grub, so we need more of them to cause the same amount of damage. But the damage they cause is pretty much identical.
Yeah, unlike other insects that we've got sort of endophytes. We don't have one for grass grub at this stage. There is that other biological controls in there. There's long-acting insecticides you can use. I've got BioShield. Is that still available? Is that still going?
Yes, it is. Yes, BioShield is there. As you're quite right, we don't have an endophyte for grass grub or its cousins, and we'd certainly love to have one because it would be a huge boon. But people are working on it, but I think we're some way away from it yet. So yes, we do have some options. As I said earlier, it's a perennial pest, and it's one we constantly have to try and deal with. And our fallback position is often to use insecticides, particularly diazinon, and that has its problems in terms of safety and environmental impact, etc. And it's also, it's going to come off the market. It's going to be deregistered in 2028, so we really need to look at some alternatives. In terms of those alternatives, the only one on the market at the moment is BioShield, as you say, and that's a bacteria. It's a naturally occurring organism, and something which scientists have been able to take out of pasture, ferment or learn how to ferment in the laboratory, and turn it into a commercial product. Now, it does have issues because it's expensive to produce, which means it's expensive for the farmers to buy. Yeah. But it has to be applied early, and when I say early, it has to be put on a grass grub population a whole year before we think that grass grub population is going to cause trouble. So it requires a bit of forward thinking, and it requires a bit of faith, and it requires a bit of money. So it's not without its issues, but it is there, and it is available. We are working on another one at the moment, and this is a thing called Serratia proteomaculans. It's same species as the BioShield bacteria, but this one works in a different way. It acts more like an insecticide. It kills grass grub and some other insects very quickly. So we can put it on a pasture and we can see a kill within sort of 2 to 3 weeks. So as I said, it functions more like an insecticide that we're used to using. But those are really the only options we have. Chlorpyrifos in Suscon green is something that people do use occasionally. That again is expensive, and that's something which has to go in its sowing. And I often wonder about the effectiveness of that, because one of our main ways of dealing with grass grub is to let the natural diseases within the populations build up. And that takes about 3 years. But to do that, we need to have the grass grub population there. So if we put Suscon green in our pastures when we sow them, and we kill those, if it works effectively, and we kill those grass grub, there's nothing for the disease to build up on. So when the Suscon green is running out after 3 years, we're actually giving the grass grub something to really go for, because there's no natural disease organisms in that soil to control them.
Yeah, that's right. When we're breaking that natural cycle, when we're cropping or cultivating, and that's when we see that spike, isn't it, 2 to 3 years after re-sowing back to grass.
Absolutely, and we understand that very well, because we're destroying the association between the natural diseases and the grass grub, and we're virtually giving the grass grub a virgin playing ground, and they just explode. So we know if we cultivate a pasture, we're going to see an outbreak probably 3 years after, sometimes 2, sometimes 4, but generally 3 years after that cultivation, we're going to see it. And we see a very similar thing after droughts. I mean, there's areas of the country now which have had very, very dry periods. Grass grub won't survive that. Without the grass grub, the natural diseases can't survive that. So we know that they will explode again once we come out of the drought period. And it's a little bit earlier than with cultivation. So we tend to see the grass grub damage appearing 2 years after the drought stops. So large areas of the country now, I would say to people, keep a very close eye on your pastures in 2 years' time if we're out of the droughts, because we're going to see widespread damage. Yeah,
that's right. Get out with the spade and have a dig and just monitor. So if you're finding grub, Colin, what sort of levels or how many numbers per spade would you say is beneficial for treatment, like cost effectiveness, I guess?
Yeah, that really varies quite a bit depending on the numbers you've got there and what your approach might be. But there are graphs around, there are figures around which you can use to actually translate the cost of grass grub density into a dollar cost, and that can help farmers decide whether or not they actually want to try and impose some sort of mitigation, or whether it's not worth their while. So, and that varies a little bit on where you are in the country, because grass grub behaves differently in different areas. Down south, for instance, most of the grass grub feeding, the serious grass grub feeding, kicks in at a time when the grasses, the ryegrasses and clovers are stopping growth. So the damage that we get from grass grub in the Otago and Southland is more severe than what we see further north, where the grasses tend to grow longer into the winter. So the feeding grass grub had less of an impact, because the grass can compensate a little bit for that damage. In terms of actual numbers, if you want a ballpark figure for what it's going to cost, if you look around about well, we know at about 200 or 300 grass grub per square metre, which isn't unusual. That's going to cost us $150, $200 per hectare. So we can afford to spend that much to try and get some sort of economic return. But it's probably, if you're really serious about this, it's worthwhile coming quite a long way down that density and start thinking, well, maybe around about 100 grams per square metre, I'm going to be losing some money here. Is it worth my while trying to treat it? But at the same time, you have to bear in mind what I call the grass grub population when it's 100 grubs per square metre, not causing a lot of noticeable damage. Is that going to put me into major damage in 2 or 3 years' time when the grass grub population bounces back, because I've also taken out the disease? So those are things you have to start thinking about. And a possible option which farmers can use when we're looking at relatively low numbers of grass grub is nitrogen. If we get out and sample our pastures in late February, very early March, we can count the grass grub then, and we can work out very, very quickly, are we going to have a problem? If it's going to be a relatively minor problem, maybe we can get away with nitrogen. That's not going to kill the grass grub, but what it's going to do is help the grass tolerate the feeding that the grubs cause. So we can, and grass grub, of course, is very patchy within a pasture. So we can get those patches which we normally might lose, so we can get them to survive, but we're also boosting the growth of the rest of the pasture. So it can be quite a beneficial thing to do, for just to use nitrogen and let the natural diseases build up.
Yeah, absolutely. We're targeting those 2 to 3 year old pastures too, like they're going into the most productive years, and you've spent a lot of money to get them there. We do need to do something, don't we, to protect them?
That's right, because we tend to think of the impact that grass grub have on production in that 3rd year, but it's much more insidious than that, because we get the outbreak, we get damage, we get patches, holes appearing in our pastures. Of course, we get weeds coming in, inferior producing plants coming in, and we're stuck with those inferior plants, loss of production for the rest of the life of the pasture. So it's not just a 1 year impact. This is something, we might lose 20% of potential production because of that damage in 1 year.
Yeah, that's dead right. Yep. I guess, we've certainly given grub. What sort of money do you think it costs our economy in grass grub a year, like given that's right through or mainly right through the country?
It's major. If
Yep.
we're looking at dairy farms, that's up to $385 million per year. If we're looking at sheep and beef, then we're looking up to around about $260 million a year.
Yeah.
Not those are the worst years.
Yeah.
We can bring it back. We can have much better years than that. But so that's a potential cost we're looking at from grass grub.
Yeah. Okay. I get. We'll move on to Porina, which is, I guess, another big problem, like grass grub. Certainly down Southland, it's a big issue around different areas. I guess one thing I've noticed this year, like the flights have been quite. We've had a lot of late flights, and they've been very staggered. Have you sort of noticed that as well?
Yes, and I think we've got several different species down here and several subspecies as well. So, and they behave slightly differently. And it's not really important for farmers to understand or to recognize the different species because as far as we can tell, most of the caterpillars do very similar damage. But it does affect the timing of when the moths fly. So you're quite right. In late October, we had a thing called Weisiana cervinata. It's one of the species fly in very large numbers. And then the following week, we had a different species, Weisiana copularis, also fly in large numbers. So we had those two flights. And then we come forward into January, and we get a second flight of another subspecies of this thing called copularis. So we get a big flight there. And so in the south, we've had those three major flights. If we go up to the North Island, then the major flights again of a thing called copularis are taking place in very late February, early March. So we've got to think about the impact that those flights then have on subsequent damage, because when the moths fly determines when the caterpillars are getting large and when we're starting to see damage, and also when we should be starting to think about controlling them.
Yeah. So that's normally about 10 weeks, Colin, is that right, after you've seen flights?
Yes, that's right. I mean, we work in a fairly broad window, 8 to 12 weeks. So 10 weeks would be right in the middle of that period. And the reason we say that is because if we're using diflubenduron dimilin, that works by stopping the caterpillars molting. So when a caterpillar grows, it molts about 7 or 8 times, goes through 8 or 9 stages in its life cycle. So we've got to get that dimilin on just before it's going to molt. And the frequency of molt is much greater when the caterpillars are small. So the first molt, for instance, takes 10 days, the next one's 14 days. But then when we get out to the larger caterpillars, when they're sort of 7, 8 months old, the time between molts then is up to 3 months. And we have to get the dimilin on within about 7 days, 14 days of when those molts are going to occur. So if we know when the moths are flying, and we know, okay, they're going to be small and molting fairly frequently in 8 to 12 weeks' time, that's when we need to get the dimilin on. And that's our best control at the moment, unless we go to endophyte. So it's cheap, it's effective, and it's got a bonus, of course, we don't take out all of the Porina, and just like grass grub, we leave enough there for natural diseases to build up and control them. If we miss that period or we're not switched on, the only options we've got for interventive control of Porina is to use an organophosphate, again, diazinon or chlorpyrifos. And it doesn't matter how big the caterpillars are, then that's going to kill them. But we're going to kill so many that we're not going to leave anything for the natural disease to build up in.
That's right. Yeah, and very hard, and everything else that's worms and everything else that's left in the soil too. Yeah.
That's right. Yes.
Yeah. Yeah. Okay. You just touched on endophyte. I guess that's one thing we've got. It's, I guess, so when we talk about endophytes, we're talking about AR37, AR1s. There's several other endophytes, but AR37 does have some control on Porina.
Yes, absolutely. We've shown quite conclusively that if caterpillars feed on ryegrass with AR37 endophyte, it will kill them. So it's well worthwhile thinking about. It should, in my opinion, it should form the backbone of all pastures that are established in Porina-prone areas. So if we know that Porina are an ongoing issue, then we should be reaching for the AR37 straight away. Give ourselves that long-term protection.
Yeah, I guess it's not a silver bullet. It's another leg on the table, really, isn't it? That gives you does give you some control, and then the other tools, the spade to get out and monitor, and then obviously your dimilin. So
yes, absolutely. It certainly, as you say, it's not a silver bullet because there are some gaps in its defences. If we get particularly large numbers of Porina, 250 per square metre, that can put a lot of pressure on the ryegrass. And of course, it doesn't protect the clovers. And the other thing we've got to think about is when we head into winter, when things get really cold, the AR37 endophyte stops producing the the compound, the chemical that normally kills the Porina. So if the caterpillars have survived until then they more or less dealing with the pasture which doesn't have the AR37 in it.
Yeah.
So we do have to think about that a little bit. And that's quite often, well, occasionally, we hear stories of AR37 failing in the face of Porina attack. And when you look hard at those, it's almost invariably because we've had large populations of Porina and possibly had a bit of an early cold snap. The compound has stopped being produced, and that's when the caterpillars get in and cause a lot of damage.
Yeah, that's right. And that can be quite devastating as well. Like, and again, numbers, if you're out with a spade, if you're finding, say, 4 to 5 in per spade, that's probably numbers that could be treated.
If we can come down a lot lower than that, actually, with Porina, we can come down to 2 per spade or 1 per spade. Okay. We know if we get Dimlin on at the right time, then treating a population of 25 Porina per square metre is actually economically worthwhile. So we can start thinking about that really, really early.
Yeah.
Okay. And again, we have to look around that 12-week period after flight. So we're looking for very small caterpillars to get our treatment on early.
Yeah, that's right. So we're into April now. Is it too late to go out with a spade and have a dig around, do you think?
No, you can certainly go out and have a bit of a dig, and that will be quite worthwhile. We're right at the down south. We're right at the limit of effectiveness for Dimlin, for diphenylpyridine. So we have to be very careful of that. Some of the caterpillars are getting quite large. Having said that, of course, if up north where the late flight comes in, as I said, the end of February, early March, those guys are still fine. They can still think about putting Dimlin on for quite a few weeks yet. And that late flight, we do occasionally get down here too. So it is worthwhile just bearing that in mind. It's not that common, or it's not that large really. We see it in a lot of places, but it's a very small component of the total flights. But again, worthwhile bearing in mind.
Yeah, definitely. Oh, well, that's sort of Porina covered off, I guess. I guess I've had quite a few calls just this late summer and autumn, Colin, around Clover root weevil. So, it's probably down south. We haven't had it till a bit later, but we're still seeing quite a lot of effects of it.
Yes.
So we released a lot of wasps. Probably it was 3 years ago now. So what's people are still wanting wasps.
That's right.
On that? Yeah.
Yeah, that's dead right. And I get a lot of phone calls every year asking if people can get hold of some more wasps, because they think it's run out of, it's not doing what it was a couple of years back. But in fact, the wasp is out there. It's very, very widely established, and it's doing an extremely good job, a much, much better job than we could ever have expected from it. But what we do see is that when we come into very early summer, normally down south it's in December, we start seeing a lot of notching in our clover leaves, and that's because we're getting a new generation of adult weevils coming up out of the soil, and they feed for a short time before they sort of fly away. Now, just before that, when we come out of winter, when we start going into August, September, the overwintering clover root weevils are starting to die off, and the parasitic wasp that gives us our biocontrol is getting desperate for hosts. So it hasn't got enough hosts there to keep itself going. So numbers of that tend to drop down quite low. So when those new adult clover root weevil come up out of the soil, there's not very many wasps there to control them. So initially they get away from the wasp, but the wasp will catch up, and it'll catch up fairly quickly. So we tend to see a lot of notching in our clover, usually, as I said, usually in December. Then it settles down a little bit, and then we get the same thing happening in February. We get the second generation of weevils coming out of the soil, and again, temporarily, there's many more weevils there than the wasps can control straight away, but again, within a couple of weeks, they will catch up. So that's the natural pattern. And that's what we see, and that's what causes quite a lot of concern to many farmers, because they see the notching and they think, I'm losing clover in a big way. And in fact, we can't accelerate what nature will do. We could give people more wasps, but there's hundreds of thousands of wasps out there in every pasture, many more than we could possibly release. So that's one thing with clover root weevil. The other thing is that often we hear about the clover disappearing from pastures, and quite naturally, clover root weevil is getting the blame for that. And it may be in some cases that it does, but more often, I think it's a combination of factors that maybe our fertility isn't quite there in the soil, we're grazing a little bit hard, and then we're getting clover root weevil on top of that. So we're getting several factors operating on the clover at once. So
Yeah.
can't do much about the clover root weevil, but we can certainly look at our grazing practices and we can look at our fertilizer applications.
Yeah, I see that quite a bit too. It's a combination of things, isn't it?
It is.
You put the grazing pressure on, and that's when your clover root weevil will actually you'll see more damage. So
yes,
yeah.
And I think it's worth mentioning too. For Southland anyway, with the very, very wet patch we had earlier on, that can actually have quite an impact on the parasitoids or the wasp performance. We know that when it gets wet, it can have quite an impact on wasp numbers, because when the wasps pupate on the soil surface, they can tolerate quite a lot of moisture, but we do lose some too. We get a lot of deaths. So that very wet event in Southland, for instance, hit at a time when we had lots of pupae in the soil waiting to emerge as wasps. So they've probably got quite a whack.
Yeah.
And interestingly enough, we see that under irrigation as well. The levels of control we get from the wasp in pastures that are under irrigation are less than in pastures that aren't irrigated. And we think that's because straight a moisture effect.
Yeah, okay. Certainly, and I guess our mild winters, Colin, how's that affecting some of these bugs, if you like? Like, certainly, are we seeing them start earlier, their generations in the spring? Are they, is that having an effect?
Yes, it is. It's not for things like grass grub or Porina. It doesn't
No.
tend to affect those so much because they're actually living in the soil and they're muted. But things like clover root weevil, yes, very much so. If we get a mild winter, it speeds things up. In a normal year, what we consider a normal year, we'd expect to see an Otago clover root weevil adults come out of the soil in late December, somewhere around about the 20th of December, just before Christmas. This year, for instance, and also in other years, we've had a very mild winter. We start seeing the adults emerge very, very early in December. So, the first couple of days of December. So it's brought them forward 3 weeks. And that can have major impacts because it just gives them a chance to actually produce more eggs. And generally, they only get 2 generations in down here. But, if we get a really drawn out summer as well, they can start squeezing in 3 like we see up in the North Island, and that can put huge pressure on things as well.
Yeah. I guess and Argentine stem will be the same. Like, you get a mild winter, and they'll start getting going earlier in the spring.
Yes, Argentine stem weevil was a really interesting insect because it's a major potential problem for us, and it's one we tend to forget. But it's widespread. It's right throughout the country. Now, it didn't used to cause us a lot of trouble in Otago Southland, and this is going back 25, 30 years. And I've been in print saying that Clover, Argentine stem weevil, isn't the major pest down here that it is elsewhere. But I've had to eat my words, because since then we get a little bit of climate warming. That's not very much. But we were sitting on a situation where there's only warm enough for Argentine stem weevil to get through one complete generation a year, and then a partial second. But with just a tiny little bit of climate warming, it can now get through 2 generations in a year. So we're seeing huge populations in some areas. If we go down to central Southland, we're looking at populations of 600 Argentine stem weevil per square metre. That's adults, not the larvae. And that's huge. By anywhere standards, that's huge. Now, we have a biocontrol agent in the country for that as well, and up until the last couple of years, that has been doing a pretty good job in most of the country. That's now lost its effectiveness because the weevil has out-evolved the wasp. But down south, it's never had the major impact on the weevil populations that it has had further north. So that's been something we've had to be aware of as well. So, but the really interesting thing about Argentine stem weevil is that we have it under control as long as we use endophyte. And this is something which is endophyte in terms of controlling Argentine stem weevil has been so effective that people have forgotten about the issue that the weevil actually poses. Now, if we go back to the days, the early 80s, late 70s, early 80s, we were looking at getting wild type endophytes out of ryegrass, and a lot of people were looking at sowing endophyte free pastures to avoid stock health issues. And pastures were lasting 3 years. So, and that's the sort of thing we'd be looking at. If we didn't have the endophytes we have now, our pastures, our ryegrass pastures, would only last us about 3 years and they're gone. So, and occasionally you hear people say that stem weevil isn't a problem. Well, it is a problem. It's one which is under control. But certainly if we started sowing the Landophyte ryegrasses, and we know this from looking at some of our annual ryegrass crops, etc., we're going to get some major impacts. So certainly something worthwhile keeping a pretty close eye on.
Yeah, I sort of recommend AO1 Endophyte as the minimum down here now, Colin. Target Southland. Of course, that's pyramine, and it's a really safe endophyte. I think it adds about $30 a hectare to your grass mix. So,
yes.
Very, very cheap insurance. And added to that, I've seen total paddocks wiped out with stem weevil, particularly if they've had a bit of trash left, just somewhere to host the weevil. And you get into autumn, and that's particularly bad time for us down here. Obviously, you've had that time for that generation. You've had one generation, if not two, and you've got a lot more numbers of weevils. So.
Yes, absolutely. That's exactly right, Brian.
Yeah.
We get the build up. Sorry.
Yeah, so I just say, be particularly important to use endophyte, but also seed treatment at that time.
Yes.
Obviously, with the way endophyte works, it takes 6 to 7 weeks to actually get into the leaf of the plant. So.
Yes, that's absolutely right. As you say, February sowings, the weevils had a chance to get through 2 complete generations, so we've got large numbers of larvae. We take an old pasture out, and whether we cultivate and don't cultivate thoroughly, or whether we sprout out and direct drill, we're not killing those larvae. All we're doing is making them hungry for a little bit, and then as soon as the new seedlings germinate, they're moving into those, and they can have some major impacts. So yes, seed treatment then can become particularly important. And just as a bit of a side note, ryegrass and Argentine stem weevil is one of New Zealand's, or certainly our only pastoral example of what we call integrated pest management, where we have a complete sort of range of tools to control a significant pest. So we've got to use that seed treatment, or at least if we don't check to see if a stem weevil is there, we've got to use that seed treatment as an insurance, and we've got to use endophyte to give ourselves protection.
Yeah, that's right. And of course, when we talk about endophytes, AR stands for AgResearch. So you guys are obviously quite heavily involved with trying to find or producing endophytes, but also research as well into new endophytes.
Well, some of our guys are, yes. I'm not. It's
right.
past my level of expertise, but certainly, yes, we have plant breeders working closely with the likes of yourselves, of course, who...
there's a bit of a consortium there, isn't there? Yeah.
Yes, yeah.
Rice and seeds, and okay. Look, well, thank you, Colin. I think we've covered off quite a bit there, but we could talk all morning, I suggest, about some of these things. So they're obviously, they do have a big financial impact, and I guess in my role, I get to go out on field and see some of the results of the damage, what it does, and it's quite heartbreaking sometimes to go to a 3-year-old paddock that's had a lot of money spent on the new pasture, and to see it devastated by some of these insects. So it is a problem, definitely a problem for us in New Zealand. So
yes, it is. Yeah. It absolutely is, and you're quite right. When you see the damage, it's happened. Now,
that's right.
If we think about it beforehand with all the pests we've talked about, we can prevent quite a large amount of it. But once we start seeing the impacts, it's too late. We've spent a lot of money, and it's gone.
Yeah. Okay. No, thank you, Colin. That's great. You've had some great insights there into what we're dealing with. Thank you.
No worries at all.
Okay. Thank you.
Cheers.
Bye.